Okay, today we're going to look at section 8.3. We're going to talk about a mean, a median, and a mode. First thing we'll talk about is the mode. The mode is the value that appears most often in the data set. If there are two modes, the data are bimodal. So if we go to the stem leaf plot below, that represents the number of times in 1 minute that different crickets chirped. What is the mode? What number appears the most often? Now it looks like this 89 is 3. And it looks like this 104 is 3. So we have a bimodal distribution, and that is 8, the stem, and the leaf, 89, and 104, or 104. Here we have the frequency distribution for the number of people who shared a residence with people in a sample. What is the mode? Well, which one appears the most often? 2, 13 times. So the mode is 2, the value, not the frequency. Next, we have the median. The median is the middle value of a data set that is listed in ascending or descending order. My recommendation is follow the practice of putting them in ascending order, smallest to largest. It becomes necessary later, so getting in the habit of doing so will make it easier later. The value that is greater than no more than 1/2 and less than no more than 1/2 of the value. In other words, the middle value. So here's how we find out what the mode is. So suppose we have a set of data with n values, and it's ordered from smallest to largest. If n is odd, then a median is the data value at position n plus 1 divided by 2. If n is even, then we find the values at position n divided by 2 and n divided by 2 plus 1. If those values are named a and b, then the median is defined by a plus b divided by 2. So find the median of the data given in the stem leaf plot. And it tells us there are 17. So n equals 17. 17 is odd. So we take n plus 1, divide it by 2. 17 plus 1 divided by 2, 18 divided by 2. So we're looking for the 9th data point. Now, these are in ascending order. Our lowest data point, 121. Then 122, 122, 125. Well, that's 4 data points right there. I need the 9th. So 130 is the 5th. 133 is the 6th. 134 is the 7th. 134 again is the 7th, or 8th. So 6. 136 is my 9th data point. That's how we can use a stem leaf to find the median. Okay, now we're back to this. What is the median number of wins? How many data points do we have? I don't recall. So we'll recount them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So n equals 30. So we take n divided by 2. 30 divided by 2 is 15. Then we take n divided by 2 plus 1. Then we have 15 plus 1. So I need the 15th and 16th data point. Well, here's the 15th and here's the 16th. So I add them together, 84 plus 81 divided by 2. That's 165 divided by 2, which gives me 82.5, which is going to be halfway between 81 and 84. So this half is one greater than, and this half is less than. 15 on each side of this number. That is the median. Okay, how about here? Frequency distribution for the number of people who shared a residence with people in the sample. What is the median number of the people? Well, how many different households are we talking about? 12, 25, 33, 39, 40. So n equals 40. So n divided by 2 is 40 divided by 2, which is 20. N divided by 2 plus 1 is 21. So I need to find the 20th and the 21st. Now that's easy enough to do. Here's the first 12 right here. Now the 20th would be 8 more, and the 21st would be 9 more. Well, here's 13 more. So the 20th and 21st are in this spin. They're both 2. So to use the formula, 2 plus 2 over 2, 4 over 2, and 2 is our median. And that is how simple it is. So next up we have the mean. And you've done this probably. You referred to it as an average most likely. Given a data set containing n total values, the mean of the data set is the sum of all the data values divided by n. So to write that in nomenclature, the mean equals the sum of all the x's over n's. So complete the mean here. We need to sum up all these numbers. And how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So n equals 9. Then I can get my calculator to add these up. 5 plus 8 plus 11 plus 12 plus 12 plus 12 plus 15 plus 18 plus 19. And my sum of x's is 112. To find the mean, I take 112 divided by 9. And I get 12.4. Now, just for fun, these are listed in ascending order. What's the mode? So our mean is equal to 12.4. Our mode is the one that appears the most often, and that is 12 3 times. What about our median? 9 plus 1 divided by 2 is 10 divided by 2, which is 5. So we're looking for the fifth. 1, 2, 3, 4, 5. So our median equals 12. This looks like a pretty evenly spread out set of data. So let's look at our frequency distribution for the number of people who shared a residence. So here I have 12 families that had one residence, because we want to find the mean. So that's 12 times 1, which is 12. And there's 12 people. Didn't we end up with a total of 40? N equals 40. Now here I have 13 people that have 2. So that's 26. Then I have 8 people that have 3. That's 24. I have 6 people that have 4. That's 24 as well. And 1 that has 5, which is 5. Now we need to take the sum of all this. That's 50, 74, 86, 91. And then to find the mean, 91 divided by 40. 91 divided by 40, and I get 2.275. That is the mean number of household members in these homes. So If the mode, median, and mean all purport to measure the same thing, centrality, which we saw here, the middle, it's all the same, pretty much. Why do we need all three? Answer is complicated, as each measure has its own strengths and weaknesses. The mode is simple to compute, but there may be more than one. Further, if no data value appears more than once, the mode is entirely unhelpful. There isn't one. As for the mean and the median, the main difference between these two measures is how each is affected by extreme values. The mean is sensitive to extreme values, while the median is not. The decision between mean and median only really matters if the data are skewed. If the data are symmetric, the mean and median are going to be approximately equal, and the distinction between them is irrelevant. So let's see which one would be best for the following situations. The data come from a survey question where the responses range from 1 to 10. What do you think? The middle value on it's going to be 5. So really the best bet here is the one that's the most often, mode. Data are fuel efficiency measures in miles per gallon for various vehicles. It's right skewed. We have something skewed now. When we have something skewed, that means there's more values on one side than the other, and that's going to throw off a mean. So we would probably use a median in this case. Same here. The data are scores on an exam and are left skewed. Again, probably going to want to use the median. The best example I can think of this really is wages at a business or home values in a neighborhood. If you ever think about it, when people are referring to salaries at a business, they don't say the mean or the average salary. They typically say the median salary, which means that half the people make more than the median, half the people make less than the median. They do that because if they took the mean and you have the CEOs of the company making millions of dollars, whereas the majority of the people are hourly employees, think it's something like fast food, it would be skewed higher than it actually is and mislead people to think they're going to make more. Same with the housing market. They typically use the median to give a better feel for what the middle value of the homes in the area are. Because again, if you're like in my neighborhood where somebody across the street tore down a house and built a multi-million-dollar home, that would skew the values in that area if you did median or mean. So again, that's why you hear it referred to by the median. Now going back to this one, I suppose we could use the mean here as well because you find the average rating as opposed to the one because but again, if the I guess if 10 is the most often, 5 people said 10 and then or 3 people said 10 and then one person said 1 or 2 people said 1, 2 people said 2 and so forth. The actual ratings should probably be on the lower end, but those 3 10s will skew it. So median might be the better way to go there, or mean might be the better way to go there, although mode could work as well. So it kind of gets tricky to tell. But that's it for section 8.3.